On July 1st, 2025, something impossible came screaming into our solar system, moving faster than anything astronomers had ever tracked, carrying ice older than Earth itself. It wasn't just a comet, it was a 7-mile-wide time capsule, frozen for nearly 7 billion years, hurtling toward the sun at over 130,000 miles per hour, and no one saw it coming. This wasn't an asteroid from the outer solar system, or some lost fragment from a familiar orbit. It was moving too fast, on a path too steep. Within hours, scientists realized what they were looking at, only the third confirmed interstellar object in human history. But this one was different, bigger, faster, older, and already starting to wake up. As its ancient surface began to sublimate for the first time in eons, telescopes around the world dropped everything to turn their gaze toward it. Hubble cleared its schedule, James Webb prepared emergency scans, and a global race began to capture every last piece of data before it disappeared forever behind the sun. Because, unlike comets from our own backyard, this one isn't coming back. It's a one-way traveler from the early galaxy, and once it's gone, it's gone. So what exactly is this 7-mile visitor made of? Where did it come from? And why are some scientists whispering that this might not be natural at all? This is the story of humanity's most ancient encounter with the unknown. And what we're about to uncover could change everything we thought we knew about our place in the cosmos. It started as just another night at the observatory. In Chile, the skies were clear, the instruments were humming, and the automated detection system at ATLAS, designed to scan the heavens for rogue asteroids, was quietly churning through images of the southern sky. Thousands of stars flickered in each frame. Most of them never change, but one dot did. Barely brighter than the cosmic background, it moved ever so slightly, just enough to catch the algorithm's attention. At first, no one thought much of it. These systems pick up space rocks all the time. Asteroids, comets, debris, nothing unusual. But when they measured how fast it was moving, everything changed. This object wasn't crawling along like the typical space rocks we track. It was sprinting, racing across the sky at speeds that made no sense. 60 kilometers per second relative to the sun. That's enough to orbit Earth in under 11 minutes. Numbers like that just don't happen by accident. Within hours, astronomers were scrambling. Telescopes in Hawaii, California, France, and Canada were redirected. Archived images were combed through. It turns out the object had been hiding in plain sight for weeks, buried deep in the star fields near the galactic center, moving so fast and so faint that it nearly escaped notice entirely. And then came the confirmation. The trajectory wasn't elliptical like an orbit. It was hyperbolic, meaning the object wasn't looping around the sun. It was flying through. A true interstellar interloper, just passing by. For only the third time in recorded history, humanity had spotted something that came from outside our solar system. The first was Oumuamua in 2017. The second was Borisov in 2019. But even at this early stage, it was clear this one was something else entirely. Faster, bigger, stranger. It didn't look like a rock. It didn't move like a comet. And the implications were staggering. They gave it a temporary designation, 11PL3Z, a string of numbers and letters that hinted at nothing. But within a day, the Minor Planet Center made it official. The third interstellar object ever discovered. Its name, 3IATLAS. 3 for its place in history, Atlas for the system that found it. A cold, cryptic name for what was rapidly becoming one of the most significant discoveries in modern astronomy. But no one realized yet just how old, how massive, or how utterly unique this visitor would turn out to be. As the observations poured in and the data became more precise, One detail stood out above everything else, and it wasn't the speed or even the size. It was the age. This thing wasn't just old, it was ancient. By tracing the object's hyperbolic trajectory backward through the galaxy, astronomers began to piece together a timeline. What they found stunned them. This object likely formed more than 7 billion years ago, meaning it predates our sun, our solar system, and even the Earth itself by billions of years. Before our planet had cooled, before the moon had formed, before the sun had even ignited its first fusion reaction, this object was already wandering the galaxy. Think about that. This isn't a relic from the early solar system, it's older than the solar system entirely. It came from a time when the Milky Way looked nothing like it does now. A time when massive stars were forming and dying in violent bursts, enriching space with the first heavy elements. Back then, most of the stars that existed were what astronomers now call metal poor, meaning they formed in an era when the universe lacked the heavier elements needed to make planets like Earth. And yet somehow, in the chaos of that early galaxy, this object formed a frozen ball of primordial ice and dust that was ejected from its birth system and sent drifting across the stars for billions of years. By examining the angle of approach, the sharp trajectory slicing through the galactic plane, scientists traced its likely origin to the Milky Way's thick disk. That's an ancient component of our galaxy, filled with some of the oldest stars known. Unlike the thin disk, where our sun resides alongside other younger, metal-rich stars, the thick disk is like a museum of galactic history. Its stars are between 7 and 10 billion years old, fossils of a time when the Milky Way was still assembling itself. If this object came from there, it means it was forged during an era of cosmic violence, when stars formed rapidly and lived short, explosive lives. And yet somehow, this one piece of frozen chemistry survived. It escaped the gravitational pull of its host system, maybe after a close pass with a massive planet, or maybe because of a near collision between stars. And then it drifted silently for ages. What makes this even more remarkable is that the comet's chemical fingerprints match this timeline. Spectroscopic analysis has revealed an abundance of water ice and silicate dust, exactly what you'd expect from a body formed in a primitive star system. The materials condensed from cold vapor in an environment that was short on metals but rich in hydrogen and helium. It's like holding a sample from the early universe in your hands. And now, for the first time in recorded history, it's passing right through our neighborhood. This isn't just a comet, it's a messenger. A frozen relic of the galaxy's youth that has somehow remained intact, unchanged, uncorrupted for billions of years. Every molecule of water in its core condensed before the Earth had oceans. Every grain of dust formed before the Earth had land, before there were continents, before there was life. This object carries the chemical memory of another time, another place, and now, just briefly, we have the chance to study it before it vanishes forever into the dark. Even before it entered the inner solar system, this ancient object began to stir. From hundreds of millions of miles away, far beyond the orbit of Jupiter, astronomers noticed something extraordinary. The interstellar visitor was already starting to come alive. A faint haze appeared around its nucleus, a soft glow that betrayed subtle activity. This wasn't normal. Most comets from our solar system remain inert until they get much closer to the Sun, typically near Mars's orbit, when solar radiation becomes intense enough to heat their surfaces. But this object was different. It was sublimating, releasing gas and dust, while still in the deep freeze of space. And that, more than anything, told scientists just how unusual this cosmic traveler really was. What causes a comet to wake up is the process of sublimation, the direct transition of solid ice into vapor. As the comet absorbs sunlight, even from a great distance, certain volatile compounds begin to heat up, and escape. In typical solar system comets, this process is mostly driven by water ice, which needs relatively high temperatures to vaporize. But this interstellar visitor wasn't relying on water. It was giving off gas at a distance where water ice should still be rock solid. That meant it had to be composed of more exotic substances, highly volatile materials like carbon monoxide or carbon dioxide, which can sublimate at much lower temperatures. These are the kinds of ices that don't survive long in most environments, but here they were, preserved for over 7 billion years in the heart of a massive comet that had never been warmed by a star until now. Astronomers were captivated. For the first time, they weren't observing a depleted interstellar object that had already spent its energy, like Oumuamua or Borisov. They were witnessing the reawakening of a frozen time capsule, untouched since the early galaxy. Spectroscopic instruments picked up faint emission lines in the comet's coma, traces of water, carbon compounds, and silicates being released into space. Each data point was a chemical breadcrumb, leading scientists back through time to the star system where this object was born. As more light reflected off the comet's coma, its composition began to take shape. This wasn't just frozen water and dust. It was ancient chemistry, preserved across galactic epochs. But the activity wasn't just a scientific curiosity, it was a crucial opportunity. The early awakening gave scientists an advantage they'd never had before. It meant they could begin observing the comet's behavior while it was still inbound, before it reached its most active stage. Telescopes around the world began scheduling emergency observation sessions. Time became a precious commodity. Ground-based facilities coordinated with space-based telescopes, using every clear night to gather more data. The longer the comet was active, the more scientists could learn, not just about what it was made of, but about how such materials respond to heat after billions of years in deep space. More importantly, the unexpected early activity hinted at just how dramatic the coming weeks could become. As the comet drew closer to the sun, its heating would increase exponentially. The square of the distance meant each step forward would unleash more volatile material, more gas, more dust, turning this ancient silent relic into a full-blown cosmic display. If this was how it behaved while still far from the sun, what would happen when it reached perihelion? What else was locked inside that hadn't seen sunlight in 7 billion years? For astronomers, it was like watching a ghost slowly take its first breath. A lifeless object from before the dawn of Earth, slowly waking up, one molecule at a time. Once scientists realized what they were looking at, an active interstellar comet older than Earth, already shedding material long before reaching the inner solar system. A single terrifying realization hit: time was running out. This was not an object they could study at their leisure. It wasn't locked in orbit. It wasn't circling back for a second pass. It was moving fast, far too fast, on a hyperbolic path that meant it would fly through the solar system once and vanish forever. Worse, calculations showed the window to observe it from Earth was brutally short. By mid-September, the comet would pass behind the sun from our perspective, lost in the solar glare. After that, it would reappear briefly in December, fainter, colder, and already racing away. In effect, astronomers had just a few months to unlock the secrets of a 7-billion-year-old time capsule before it was gone forever. The response was immediate. Ground-based observatories dropped routine work and pivoted to focus on the interstellar object. Telescope time, normally booked years in advance, was cleared on short notice. The Hubble Space Telescope, one of the most in-demand scientific instruments ever built, cancelled scheduled observations to focus on the comet. The James Webb Space Telescope, only recently launched and just beginning its scientific operations, adjusted its tightly controlled observation plan to make room for two critical windows, one in August, before the comet disappeared behind the sun, and one in December, when it would emerge again for a final goodbye. Observatories in Chile, Hawaii, Spain, Japan, and across Europe all joined the race, pointing their massive mirrors at this ancient visitor night after night. Data was collected, analyzed, and shared almost in real time, breaking down the usual barriers between institutions and nations. In just a few days, this became one of the largest coordinated astronomical campaigns in modern history. But it wasn't just elite observatories that got involved. Amateur astronomers around the world, operating with nothing more than backyard telescopes and a passion for the stars, joined forces. Hundreds of citizen scientists contributed observations through the Unistellar network, capturing images, stacking exposures, and tracking the comet's movement. Their modest instruments couldn't compete with the power of space telescopes, but their global distribution allowed for near-continuous monitoring of the object as Earth rotated. Where professional telescopes faced weather delays, mechanical issues, or scheduling conflicts, these backyard stargazers filled the gaps, ensuring not a moment was lost. In an era where science often feels like a battle of billion-dollar machines, this was a rare moment of unity, humanity racing together to observe something that had waited eons to arrive. Behind the scenes, the pressure was mounting. Every clear night was a gift. Every clouded sky, a tragedy. Equipment failures became minor disasters. Weather forecasts were watched like launch windows. The comet's trajectory meant it would become harder to observe by the day as its angle shifted, and it drew closer to the blinding light of the sun. And the closer it came, the more intense its activity became. Sublimating, shedding gas, building a coma, developing a tail. This was when the most important changes would happen. This was when the most volatile compounds would be released. And this was when Earth would lose sight of it entirely. No one wanted to say it out loud, but the frustration was real. The universe had delivered one of the rarest, most ancient objects ever discovered, and scheduled its most dramatic moment during a 2-month stretch when our planet would be completely blind. Astronomers knew the rules of cosmic timing didn't bend to human convenience. But still, the sense of urgency was palpable. This was a once-in-a-civilization discovery, and it was slipping away one rotation at a time. As the comet raced inward and astronomers worldwide scrambled to gather every last photon of data, it became clear that Earth wouldn't be the only planet in its path. According to refined orbital projections, the object would pass unusually close to Mars, just 0.4 astronomical units away, or about 37 million miles. That's closer than many spacecraft ever get to the red planet. And unlike Earth, which would lose sight of the comet behind the sun during its peak activity, Mars would have a front row seat. The timing couldn't have been more perfect or more frustrating. While our planet turned away, Mars would be staring directly into the heart of the cosmic storm. The opportunity wasn't lost on planetary scientists. Mars is home to a fleet of robotic observers, satellites orbiting above, rovers crawling across its dusty surface, and instruments tuned to study everything from geology to atmospheric conditions. Suddenly, these tools had a new target. The Mars Reconnaissance Orbiter, with its high-resolution camera and spectrometers, was uniquely positioned to capture images of the comet during its closest approach. It could potentially resolve features in the coma, measure outgassing, and even study the tail's structure. Mars Express, a European orbiter that's been circling the planet for over 2 decades, was also lined up for potential observations. Its instruments, though older, could still contribute valuable data about the composition and behavior of the comet's emissions. But what truly electrified the community was the possibility that fragments from the comet's tail, tiny grains of dust, ejected into space at interstellar speeds, might actually enter the Martian atmosphere. While the comet itself posed no threat of impact, its tail stretched for thousands of miles, and some of that material could drift toward the planet. If even a small number of particles struck Mars, they could create faint meteor trails, cosmic streaks of light racing across the thin Martian sky, visible to cameras on orbiters or even surface rovers like Perseverance. For the first time in human history, we might witness material from another star system burning up in a planet's atmosphere, captured not by chance but by design. This flyby also revealed just how strange and convenient the comet's trajectory really was. It wasn't just passing near Mars, it was sweeping through a part of the solar system where multiple spacecraft could observe it from different angles. Mars orbiters would catch it at its peak. Earth-based telescopes would track it before and after perihelion. Even Venus, despite its overwhelming brightness, would briefly sit near the comet in the sky, offering potential calibration points for photometric analysis. For a completely unplanned event, the geometry was almost too good to believe, and that's when the murmurs started. Not from the mainstream scientific community, but from the fringes, the voices who saw patterns where others saw coincidence. Some pointed out the comet's near-perfect approach window to Mars and its timing around Earth's solar blind spot as suspicious. It passed close multiple planets, became invisible just as it reached maximum activity, and then reappeared only briefly before fading forever. It was almost as if the visitor knew exactly when and where to arrive, staying just long enough to tease us with answers we couldn't fully uncover. Of course, the prevailing view remained rooted in physics. Gravity is chaotic. Space is full of close passes. The solar system gets brushed by cosmic objects all the time. But this one felt different. Not just because of what it was, but when it was. It came at a moment when our technology was finally advanced enough to study it from multiple worlds. As Earth's view vanished, Mars picked up the baton, as if the universe itself had arranged a celestial relay, passing the ancient message from one observer to the next before the lights went out. As the data poured in and observations intensified, something began to shift, not in the comet itself, but in the way people were talking about it. The science was remarkable. A massive, active interstellar comet older than Earth, passing unusually close to Mars and sublimating from extreme distances. But beneath the surface of the scientific consensus, another narrative was quietly taking shape, one that questioned the assumptions we were all making. What if this thing wasn't entirely natural? It didn't start in the headlines or with the mainstream astronomy community. It began, as these things often do, with a single paper. Harvard astrophysicist Avi Loeb, already known for stirring controversy with his theory that Oumuamua might have been alien in origin, published a speculative paper suggesting that this new object, too, might deserve a second look. He wasn't claiming it was artificial, but he was asking whether we could be absolutely sure it wasn't. The timing, the speed, the trajectory, they all raised questions worth asking, at least in his view. Why did the comet awaken so early, while still beyond Jupiter? Why was it so perfectly positioned for a Mars flyby? Why did it reach perihelion, the closest point to the Sun, precisely when Earth would be unable to observe it? Loeb pointed out that the object's hyperbolic eccentricity over 6.2 was unusually high. That meant it wasn't just passing through the solar system. It was blasting through it faster and more steeply than either Oumuamua or Borisov. He speculated, albeit cautiously, that such a trajectory could have benefits for an artificial probe, especially one designed to deploy smaller instruments to multiple planets. The flyby of Mars, the near alignment with Venus, the December reappearance just long enough for telescopes to catch a final glimpse, it all seemed to him just a little too perfect. Naturally, the backlash was immediate. Scientists from across the spectrum criticized the paper as baseless, speculative, and ultimately misleading. Astronomer Chris Lintert from the University of Oxford called the idea nonsense on stilts, emphasizing that the object's behavior, its coma formation, its outgassing, its spectral fingerprints were entirely consistent with known cometary physics. Others warned that promoting such theories even tentatively risked undermining public understanding of how science works. Extraordinary claims, after all, require extraordinary evidence, and so far there was none. But even among those who rejected the alien theory, many acknowledged something deeper. The timing was frustratingly inconvenient. The comet really did seem to show up at a moment when human observation was both possible and limited, and its sheer size, over 7 miles wide, made it fundamentally different from every other interstellar object ever detected. It wasn't just another data point. It was an outlier, and outliers always demand scrutiny. In the public imagination, though, the idea caught fire. Social media threads speculated about alien probes hiding behind icy shells. Videos racked up millions of views asking if this was our first contact, a celestial scout slipping silently through our system, watching, measuring, vanishing. Most of it was harmless curiosity, a blend of science fiction and cosmic wonder. But it did something important. It reminded the world that space is still full of unknowns, that for all our equations and observations, we're still just scratching the surface of the mysteries around us. Ultimately, the alien theory faded into the background, drowned out by the overwhelming evidence of natural origins, but the whisper of possibility lingered. Not because it was likely, but because it was human. Because when something older than Earth itself appears out of nowhere, races across the solar system faster than anything we've ever seen, and disappears behind the sun at its brightest moment, our minds can't help but ask, what if? Despite the speculation, the numbers spoke clearly, and what they told scientists was just as extraordinary. As more spectroscopic data came in, the evidence of the comet's natural origins piled up, but so did the implications. This wasn't just another passing rock. It was a fully preserved piece of galactic archaeology, frozen during the earliest chapters of the Milky Way and ejected from its birth system sometime after the first generation of stars began to die. It had survived billions of years in interstellar space, its volatile compounds intact, its surface virtually untouched. What we were seeing wasn't just a comet. It was a chemical fossil, carrying the molecular fingerprints of a time before Earth even existed. And what made it even more remarkable was what it told us about the galaxy itself. For decades, scientists believed that interstellar objects must be out there, chunks of ice and rock flung from other solar systems, wandering between stars in eternal silence. But until 2017, we had never confirmed one. Then came Oumuamua, fast and strange, shaped like a needle and oddly silent. In 2019, Borisov followed a more traditional comet, but still interstellar, and now this 3IATLAS, dwarfing the previous two, not just in size, but in scientific value. 3 confirmed visitors in less than a decade. That wasn't coincidence, that was a pattern. This changed everything. If we'd found 3 in 8 years, using limited survey coverage, there had to be thousands, maybe millions passing through the solar system, most going completely undetected. The odds of spotting one depended on its size, speed, and trajectory, and even then, it had to appear in the narrow slice of sky our telescopes could see at the right time. That meant we were only catching the tip of the iceberg, and if this was what the tip looked like, the rest must be staggering. The realization sparked a scientific shift. No longer was the focus on just understanding this one object. It was about preparing for the next one. Astronomers began pushing for more dedicated interstellar surveillance programs, telescopes optimized to catch fast-moving, high-eccentricity objects before they slipped away. The Vera Rubin Observatory, nearing completion in Chile, became the crown jewel of that plan. With its massive field of view and powerful wide-field camera, it promised to capture a movie of the entire night sky every few days, perfect for spotting fast-drifting visitors long before they reached perihelion. But 3IATLAS had already done more than prove a population existed. It had expanded our understanding of where interstellar objects could come from. The sharp angle of its trajectory pointed to the galaxy's thick disk, home to stars far older than our own. That meant this wasn't just any object. It was ancient, even by cosmic standards. The chemistry backed that up. The lack of complex molecules like CN or OH, which are common in solar system comets, hinted at formation conditions unlike anything we see locally. Instead, this comet was rich in carbon dioxide, silicate dust, and simple water ice, exactly what we'd expect from a metal-poor planetary system in the early galaxy. And if that held true, then every molecule boiling off this object was telling a story about a time and place we've never touched before Earth, before the Sun, before the planets formed. A time when the universe was still assembling its ingredients for life. Every spectrum was a chapter. Every observation was a page. Scientists weren't just studying a comet. They were reading a chemical diary from the galaxy's forgotten youth. So while the idea of an alien probe made for flashy headlines, the reality was just as powerful. We were watching the past fall apart in real time, gently unraveling in sunlight, molecule by molecule before fading into darkness. And the only real question left was, how many others have we missed? As the final days of visibility approached, astronomers around the world worked through sleepless nights, knowing this was the last time they'd ever see this object. The comet, still shedding the ice and dust it had held for billions of years, was fading into the cold. By December, it would re-emerge from behind the sun, just long enough for one last look. Dimmer now, quieter, its most volatile materials already lost to space. Observations during this brief reappearance captured its final breath, a last whisper from a visitor older than the Earth itself. And then, like a ghost slipping back into the dark, it vanished. But even as its light disappeared from our skies, the impact of its passage was just beginning to unfold. What we'd witnessed wasn't just a natural event, it was a reminder that the galaxy is still alive with motion, still sending us messengers from places and times we can barely comprehend. This object didn't belong to us. It didn't even belong to our star. It came from somewhere else, perhaps a long-dead planetary system orbiting a star that burned out before life ever touched Earth's oceans. It drifted through the void for eons, untouched, unseen, until finally, by pure chance or cosmic design, it passed through the narrow slice of space where a species of curious apes had just developed the tools to recognize it. And for a moment, we looked up and understood. We understood how small we are in the scale of the cosmos, and how extraordinary it is that we were able to meet this ancient traveler at all. The odds were against it. The timing was impossibly tight. A few days later and it would have passed unnoticed. A few years earlier and we wouldn't have had the instruments to study it. A few centuries ago we would have never known it existed. But in this sliver of time, in this one narrow window of cosmic history, we were here and we saw it. The data collected will be studied for decades. Papers will be written. Models will be revised. New instruments will be designed with this event in mind. But beyond the science, beyond the chemistry and the orbital dynamics and the infrared spectra, this comet gave us something even more valuable: perspective. It showed us that the galaxy is full of stories waiting to be told, stories written not in words but in water ice and silicate dust and ancient trajectories through space. It reminded us that the universe isn't static. It moves, it changes, it speaks. And when it does, we have a responsibility to listen. This time, we did. We caught it, barely. We recorded its glow, we read its light, we captured its final breaths as it passed through our solar system like a cosmic time capsule. And then we let it go. Back into the dark, back into the silence, back into a universe that is far older, far larger, and far stranger than we often allow ourselves to imagine. But the story isn't over, because now we know where to look. Now we know they're out there. Other messengers, other relics, other visitors that will pass through, carrying pieces of distant star systems, of forgotten epochs, of cosmic truths that haven't yet been written into any textbook. So, maybe the question isn't whether we'll see another one. Maybe the question is, will we be ready for it when it comes?